Alright, here's a short video on writing node voltage equations to solve a simple circuit, and then more importantly, once you have the node voltage value, how you can use that to find other unknown things about the circuit. So in this particular case, let me walk you through what we're going to do. We're going to write the node equation for V alpha, and once we do that, we can solve for V alpha. And then from there, once we have V alpha, anything else in the circuit should be pretty easy to find. We're going to illustrate that by finding the power associated with the 5 ohm resistor. Okay, so I've replicated the circuit here. And so let's write the node equations for V alpha. Okay, so we talked about in class that we draw these currents coming out of the node and that the sum of the currents at any node is 0. Okay, from there we need to find the current I1, and so we notice there's this branch, and it includes a 5 ohm resistor, a source, and a 3 ohm resistor. So we can come up with the equivalent resistance for that branch and write down that I1 is V alpha minus 40 divided by the equivalent resistance, which is 8. All right, so that's the hardest one. The next one is I2. So I2, you have V alpha here, ground here, so that's 0 volts. So this would be V alpha minus 0 divided by 2. And then finally, I3, we have the current source in that branch. It's pointed the wrong way, so I3 would be minus 3 amps. So there's the equation that we need to solve. And so now it's just a matter of doing algebra to get that equation. So let's do that real quickly. All right, so I like to factor out V alpha, and then I have 1/8 plus 1/2. And then you have a negative 40 over 8 plus a minus 3 equals 0. So I can move those to the other side. That'd be 40 divided by 8 plus 3. And now I need to find a common denominator, which on this side of the equation will be 8. So that would be 5/8 is equal to 40 plus 3 times 8 is 24 over 8. The 8's cancel. So V alpha is 64 divided by 5. Okay, and that's in volts. All right, so that's part B. So you see that's pretty simple to do. Next, we go back and we look at this circuit. If we know V alpha, which we now do, then the voltage across the 5 ohm resistor is simply V alpha minus 40. Okay, and so once we know the voltage across it, we can find the current through it. All right, so let me write that down. The power for the 5 ohm resistor is the voltage across the 5 ohm resistor times the current through the 5 ohm resistor. We know the voltage is V alpha minus 40. And the current would be V alpha minus 40 divided by 5. V alpha is known because we just started this video because I actually made a mistake when I said that P5 ohms is V5 times I5. That is actually correct. The mistake comes from what is V5. So in the video, original video, I put the V5 is V alpha minus 40. All right, it's really easy to make that mistake because you're so used to looking at these dots. All right, here's the dot V alpha. I see this 40 volt source. That's where that mistake came from. Okay, why it's a mistake is this point is not 40 volts right here. This point is not 40 volts because I'm going to have a voltage difference across the 3 ohm resistor. If I continue I1 in this direction, there's going to be a voltage difference across that resistor. And so when I move the dot, I have to account for that voltage difference across that resistor. So this is going to be 40 with, it's going to be a different number. It's going to be 40 plus the voltage rise, I guess it would be in this direction. All right, so how would I solve this? Okay, well, I could figure out what that voltage drop is, and I can go through and continue in that direction. But at this point, I'll back out of that solution. And one of the things we've talked about is there's different ways to calculate power for resistors. And one is I squared R. Okay, so I can take I1 squared and multiply it by the 5 ohms. All right, so we know power is I squared times R, and it's V squared over R as two other alternate formulas for power for a resistor. Okay, so I'll get rid of those. So from there, I know what I1 is. All right, so I1 is, I'll go back to this equivalent circuit that was given before, where I combined the 3 ohm with the 5 ohm to get an 8 ohm. All right, and so that would be V alpha minus V40. Remember, the picture I have now is plus minus 40, and then I have 8. So this is an equivalent circuit for this branch right here. Okay, so if I know that's V alpha, then this is 40 at this point, right? Because there's no resistor in this branch, and so this point, this dot is 40 volts. Okay, so I1 would be V alpha minus 40. I said V40, but minus 40. Oh my gosh. Divided by 8. Okay, then I'd square that and I'd multiply by 5. And I know V alpha, so I can actually do that calculation.